Now let's have a look at some mixed problems and ones where we're not just locked into one particular method, and see if we can find ways to look at a problem and go, okay, this is the method I'm going to attack it with. So remember, with factorizing, it means to express as a product. We're trying to get it as a product, so getting brackets multiplying by each other. So what we need to do is keep in mind as well that we need to factorize fully. So like something like this, if we end up with 2x plus 6 and x minus 5, 2x minus 6 still contains a factor of 2. It's not absolutely correct. It's factorized. Not a problem. And if the question says factorize, then technically you could probably get away with it. A lot of times you probably won't. And that's why a lot of times it will say fully factorized, to make sure you get to do that. So if you do see that word fully factorized, make sure you keep looking for more than one step. Like technically this has 2 steps. Factorize the first step, factorize a common factor out, so the 2 comes out first up, and then factorize the trinomial to be left into the 2 brackets. So be careful with that. So if you can use this idea. If it's got 2 terms, what we try and do is look for the highest common factor first. I always do. Look for the highest common factor. If there's no common factor, then it's either going to be a situation where there's going to be a difference of 2 squares or the sum or difference of 2 cubes. So it'll be one of those 3. So have a look for those as a rule. If it's got 3 terms, again, highest common factor, and then factorize that trinomial. Okay, it's get the highest common factor out. Usually there's not as won't do it, and there's going to be a trinomial. That's just the nature of the course. We're not going to be dealing with very trivial type situations in this course. That's junior mathematics. You're big boys now, so you'll be able to do big boy maths. So you're going to have problems that are going to be more than just highest common factors in a lot of terms. If it's got 4 terms, again, I haven't put it in, but really should, again, look for a highest common factor. If we've got a highest common factor, take it out straight away. Makes life easier, but also it needs to come out. And then look to group them. Get that grouping in pairs happening if that's once you've done the highest common factor or there's no highest common factor to do. It's usually needs to go a bit more than that. So go the grouping in pairs. So let's have a look at some problems. So again, first thing I'll do, have I got a common factor? No, I haven't got a common factor. Let's start to pick up the pairs there. So I've actually grouped these 2 and factorise the x out, gives me a p plus q. These 2, factorise the 6 out, gives us with the p plus q there. So when I see that, the p plus q, that can be factorised out. So again, I'm looking to get that bracket the same. So whatever you get in the first bracket, then that's what you should be looking to get in the second one. 2 is just looking at a situation where we've got our highest common factor. Yes, that one's pretty simple. It's not supposed to be too hard. Again, try not to read too much into it as you go through. Try and get a common factor. None there. I've got an x cubed there. So it starts to tell me, wait on, can I get the cube root of 1000? It comes to 10. So 10x cubed, cube root of 1 is 1. And then I apply the rule where that would be this term, the 10x all squared. The last term would be 1 plus 1 all squared, and the minus 10x times 1 gives us minus 10x. 3 terms, no common factors, so I can't take anything out. I'm left for a trinomial. So I do my cross method. 3x times the x gives me 3x squared. Minus 1 times minus 5 gives me 5. Now I'm going to be both negative as well, remember, because that's positive and that's negative. So 2 negative numbers multiply to give me the positive. So all it's a case of working out is, okay, does the minus 5 go in the bracket with the 3x, or does the minus 5 go in the bracket with the x? And trial and error again would tell me that it's going to be this situation. 2 terms, again, no common factors, but squared, so we can factorize and get difference of 2 squares. Okay, this one, 3 terms, no common factors, close, but not all, nothing's actually common to every term. So again, we're looking at a trinomial. 5x and x, 2y minus 2y and y. Again, it's just a case of, well, that's minus and that's minus, so working out which one's positive and which goes where. Again, trial and error, get your cross method going, or your other methods, whatever. But a lot of times it will be a trial and error. Again, the more you do, the better you're going to get at picking it. P cubed, 125, Q cubed, R cubed. Again, no common factors, but it's a difference of 2 cubes. Apply that rule. Question 8. So this one here, no common factors. Okay, unfortunately, can't make it any simpler. We need to group them in pairs. So I picked the first two and factorise the x squared out, gives us x minus 7. Pick the next two, minus 8 comes out. And remember, we saw this before in another video. Minus 8 gets factorised out, but because we're factorising negative out of the positive, that term becomes negative. Again, we should be able to expand that back to that. So again, we should know whether we're doing it correctly because we can expand it and get it back. Minus 8 times x is minus 8. Minus 8 times minus 7, positive 56. Now, minus 7, x minus 7 factorises out. So that's nice. And we've got left with a term. And that's difference of two numbers and one squared, technically both squared. And so even though the 8 doesn't come down to a nice square number, we can put it as a difference of two squares to get it and take the square root and get the root of 8, because root of 8 times root of 8 would give us positive 8. They'll did that number 8 there, and with a negative, because it's the two terms, the two brackets are the same, except we've got different signs. So that's completely factorised. We need to get down to there, and we've used two techniques. We've grouped them in pairs, and then we've used a difference of two squares to get that factorisation. We've done the same thing there with this one, but we saw this one earlier, so we can you can go back to previous videos to set that one, or have a look at what we've done there. Remember, with the one was in front there. And the same thing with this one here. If we look at this one, okay, we've got the b plus c all squared, ab plus ac. Well, again, nothing's common, but we can factorise this to get the a outside of the b plus c. And what's common here now is a b plus c. So we're left with a b plus c there, factorising out, and then minus a b plus c, because b plus c times b plus c times b plus c will give us b plus c all squared. So that's a little bit tricky with that one, but that's the complete factorisation of that one there. Start with it was partially factorised. So we're going to, again, these are examples of what you need to do. Some of them are hard, and you've got to be really careful, but we need to be excellent at this. Just can't be good or pretty good. We need to be excellent at it. That's the type of standard we need to achieve. So need to practice, ask questions in class, make sure by the end of the first few weeks of school this term, you are really confident with your algebra, because we need you to be very confident for this work in the next 2 years in this course, because that will really set you up for success as we go through it, and a better understanding of the work we're going to do on calculus in the future.